know why. Let me check. Ah, right now I'm okay. I'm on the air, I think. Check it, please. Right? It works? Is it working? Yeah, finally. Check the sound level, please, also. Could you check it? Okay? Yeah? Okay. So, what we're going to do today, we've got here we have 6 routers here, the Vyos routers. 3 of them are configured with the RIP protocol, and we're going to configure the other 3 over here. And then, if we have time, we're going to make the configuration with OSPF with 3 areas, perhaps even today. So, for configuring these routers, the Vyos routers, they are a fork from Vyatta routers, and also they are quite good, and they are over Debian protocol, Debian open source system. So first of all, let's check that we don't have no RIP here. Show protocols, and we had only 2 networks. Let me check on the drawing. The diagram is quite important. So I'm on R3, and I added these 2 networks. I have to give this one, I have to add also this one, this network. Then I'll go via SSH to this router, making the configuration of the RIP protocol, and so on, so on. So first of all, the networks, they are 10.0.13, and the other network will be 192.168.40, I think, 0/24. Let me check on the diagram. Correct. And also the other network is 10.0.0.12, and the other network will be 10.0.0.12/30. This network connects R3 to R4, and after we have to inform what are the passive interfaces. So set protocols passive interface. In this case, RIP passive interface. In this case, the passive interface is this network, the HT2 network. Why? Because we don't want that the router sends the routing information to this branch of the network. So it will be 192, interface HT2. So right now the protocol is almost configured. We're going to say also to redistribute connected, so it will send information to all the networks to who is connected. Let's make commit and save. And if you go right now, if you do show IP route, we'll check that you've got all the RIP information, and this route over here are from RIP protocol. This is the network 192.168.10. As you can check here, it's a network here of the R1. So the R1 sent it already, the information of the networks that he knows, to the R3. And the same here, the 20, the 30, and the 40 is directly connected. You can also route RIP, and you only check what are the routing that he received. So these are the networks that now he knows, and were sent it in this case by the 10.0.0.10 and this is the connection from the R1. R1 send it the information through this interface HT3. That's 10.10.0.10, and this is the weight of the protocol, 120 normal and 2 jumps. He says to reach this network. So right now we have also another. We are doing SSH since. Let's check also the diagram you've got here. CentOS, we are connected, and right now we are connected by SSH to R3, and now we can test and check if you can get to this IP address. And so we'll do a ping 10.00.13, and it reaches. If you make a trace route, we'll find out that we have 2 jumps, 2 hoops until we get to this network. So the gateway and then the interface. So right now the RIP protocol in this for these 3 routers, R1, R2 and R3, are already configured. Let's configure R4, R5 and R6. Then we're going to do some tests here, and perhaps we'll stop, and we'll continue with another live stream with OSPF. So let's now make an SSH to the IP address of 40. Now we can also do a trick here, adding, if you make an echo 10.00.40. This is IP address of HT1 from R4, and we say that's R4. We'll send it into the host file that's on the ATC net folder. Right now you can make an SSH. I'm going to make an SSH Vyos, the username, and now the R4, and it should go to that network, but it's not going. Why? Ping 10.00.14. No, it's not pinging. Houston, you have a problem here. Why? Let me check something else. Route tel. Oops. No, sorry. What is route tel? Yeah, he has a gateway. So why he doesn't know this network? Check. Let's go to R1. SSH Vyos to 192.168.10.1. Let me show IP route, and you should connect this network. It's on RIP. Ping 10.00.40. No, it's not pinging. Something wrong here. Oh yes, of course. Of course it's not pinging. Today I didn't have my pills. This guy over here doesn't know where to send the package back. The package are arriving here, but he doesn't know where to send this information back. So I'm going to do an SSH from R3, SSH Vyos at 10.00.40. Okay, the password. Now, if you go and make a TCP dump on HT1 that connects R1 to R4 to R3, to check if what is coming about ECMP. And right now I'm going to open another shell here. Ping 10.00.40 is pinging, and as you can check here, I'm going to stop it. the package arrived from 192.168.10.9. This is the IP address of the CentOS. This is the IP address of the CentOS. So the package is arriving to this router, but this router doesn't know any, doesn't have any routing or any route to send the information back. So it's quite normal that it's not answering to the SSH or to the ping protocols from here. So you have to create RIP protocol before here, and then we'll see that we can enter by SSH or doing a ping. So let's configure set interface loopback low address will be 4444/32. It's himself, and you can give a description here if you wish to. This it will be R4 loop back adapter, and we can also set protocols, RIP network, and network will be 10.0.0.0.40/30. Oops. Sorry, not 40, 12/30, and it will be also the network 60/30 and the network 24, I think. Oops, 24. Let me check here on the diagram. Yeah, it will be 24, the 60, and the network will be 12. And also this network here, HT2 has this network, so it will be 192.168.60.0.24. Now we've got the passive interface here. The passive interface will be HT2, and we'll say that to redistribute distribute connected. And right now commit, save. If you run show IP route right now you see that he receives all the routing from the other routers. Look, right now for the network 192.168.10 we have to have 3 hoops or 3 jumps, and it was received by the IP address 13, and the IP address 13 is this IP address. Okay, so right now it's possible for us to make an SSH enter directly to this router. Let's check if I'm right. So here I am. So SSH, the user Vyos, and IP address it's R4, and right now we are on the R4 router. So we have to continue. I'll do an SSH for the, first of all let's ping. I'm here on the R4. The IP address of this router is 70, and I'm going to ping the R5. It's 80, 10.0.0.80. So ping 10.0.0.16, right? Oops. Oh, it's not a broadcast. This is network. This is 80. Yes, almost. I almost get it. Sometimes I miss. It's my little. So SSH Vyos at 10.0.0.80. Password. We are on the R5. Let's show IP route, or even show IP RIP directly. We then have no answer because you don't have no configuration on RIP protocol on this router first of all. And so let's configure it, and then set interface loopback low address. We're going to use the same thing. The loopback address IP address in this case is not important, but in OSPF it will be, because we can force the router to become designated router DR using the IP address of the loopback address. So right now we've got set protocols, RIP network will be 10.00.16/30, as we can check here. So what are the networks that this router knows? He knows this network, he knows this one, and also this one. So the 20 and the network for the hosts 192.168, 60 I think, 70 and 80. So 70/0, 24, and then 80/24. You've got also passive interfaces here. It will be HT2 and HT3. Oops, and HT3, and we're going to send him to redistribute connected. Okay, commit, save, and right now show run IP route. Show run, sorry, not show run, run show. That's Friday. Show run run show IP route, and here we can check all the networks. He knows 10, 20, 30, 40, and so on. So he knows every network. These are directly connected to him, so he knows every network. If we do show IP RIP directly, you'll find out all the networks that were announced to him via the RIP protocol. Here they are, all of them. The IP address that bring it, of course it's only 70, because this router only knows the networks that are in this side that were announced by this interface from H4, or router 4, sorry, HT3 from router 4. So these are the network. If you'll do also IP route RIP or another, it'll give you all the RIP networks, and RIP status will give show IP RIP status. It will give you more information about the RIP protocol. These are the interfaces, how many times he sends information about the networks that he knows, when he received it, the routing networks that he has, the passive interfaces, and the gateway that he is now considering is this IP address. It's the only one that he has contact to from the RIP configuration. So it is also possible. Oh, we're still pinging here. Got a float here of pings. So right now we can make SU. We can also IP addresses networks 40 80, right? 80, and it's R5 and ping R5. Let's check. Yeah. Okay, so SSH Vyos at R5. Yeah, password. And right now we are on R5 router. So if you do first of all, let's opening here another shell. If you do almost get the password. Sometimes this is a slippery password. Again, if someone knows the password, please tell me. Ah, I get it. So netstat minus INTP grep port 22. Now we have SSH server working on here. This is where we are connected. This is our port, and right now is connected directly. This is one directly to the R3, oh sorry, R4 router and R5 router directly connected, and then we have also two other connections. This is also listening on IPv6 connection. So we are on R5, and let's make the last RIP configuration here on R6. So SSH Vyos, and then we'll say it's 10.00.22, isn't it? Yeah, 22 password, and we are on R6. You can begin to see what are the routes that he knows. He has no routing, and let's make the configuration config, and right now we're going to config set interfaces, loopback, low address 632. Now RIP network, sorry, not interfaces, protocols. RIP network will be now the R6. So we've got networks, it's 10.00.24, 10.00.20, and this one 192.168.90. So 10.00.24/30 and 20 and 192.168.90.030. Oh, I missed this delete. This is wrong. This is 24, right? And distribute connected, and also passive interface. In this case, it's only HT0. Correct? Let me check. Yeah, this is the only passive interface of this router. So commit, save, and right now exit show IP route. Here right now you must know all the routing protocols. As you can see, he knows all the networks 10, 20, 30 till 90, also the networks that connects the routers, and he knows also the loopback addresses of all the other routers. And from now on, if we're going to here on terminal, if you make a trace route to or till R6, we'll say 10 and 10.00.24, I think. Let me check. No, 25. This is network, and as you can see, you're going to route, you're going to 10.01, 9, and 25 here. So it passes here 10.01, then here 10.009, 10.50, and then he reach the other end. Okay, 9 and 25 at least, because this is the IP address of the next router. So right now in this network, if we had here some hosts, let me put here an host. If I place here an host, it doesn't matter which host, this host would have connection to everywhere. How long is this video on? How long am I? How many minutes? 20 minutes? How long is the live stream? 24. Okay, I'm going to just finish with a question. Now, let us think about, I'm here on R1 and I can ping, for instance, Google, right? Google.com, and you have an answer, a DNS resolution also. I'm pinging Google. Okay. Now, question. If I place here a client, it doesn't matter which client it is. I'm going to bring someone here. This one, for instance, it's an XP, an old XP machine. Okay, just let me configure the network interface. Not green. It will be R4 south, right? South. Sorry, R4 south, and the IP address will be properties. The R4 will be some IP from this network. So 192.60. Or it could be 10. It could be 10, and gateway will be 1, and the DNS. Sorry, it's here, and the DNS could be the Google DNS or any other one. Doesn't matter. So right now, let me check. So we placed here another. This is a client. Windows client in this case, Windows XP, and the question is, first, can this machine go to the one? Can he browse the one, or with a browser or anything else? First of all, let's check here. Oops, I'm going to. So ping, first of all, 192.168.10.1. Sorry, 61. Let's check our gateway. So he's reaching the gateway. So right now, this client reached the gateway. So can he pings any IP from the one, or can he pings this interface here, the 10.00.10? Answer. Is it possible? Are you still sleeping? Are you wake up? Is it possible from this client here to ping this interface? Why? Because he has RIP. So first of all, let's check how is the routing protocol on R4. So let me see. I got here R4. Oh, it doesn't matter. I'm going to make another connection here. SSH Vyos at R4. Okay. Yes. Password. I'm on R4. I can ping 192.168, of course, 60. 10. This is the IP address of the XP, the Windows XP. So it's possible. And show IP route. Again, we have a problem with the show. Show should be written differently. IP route, and is pinging. Sorry, this is the networks. He knows all the networks, including the networks that connects. Here it is. This is a network that connects R1 to R3. Okay, let's check. 10.0.0.8. He knows this network, so he can send package to that interface. Let's check. Ping 10.0.0.10 is pinging, and if you make a trace route 10.0.0.10, it gives 3 jumps, so it's okay. So first of all, can the XP ping this interface? Yeah, for sure. Ping 10.0.0.10, and it receives a response. Of course, if you make a tracer here to 10.0.0.10, we'll check that we'll have 10 jumps, I think. Oh, sorry, 10 jumps, 3 jumps. Well, perhaps it will respond someday, but here it is. It eventually sends the information back. So the question is, can this one get outside, for instance 888, or can he navigate? So these are the jump. I'm going to open here a browser. So what's your site? Home site is cop. Sorry, Z S K O cop dot EU. Oh, thank you. Okay. No, it's not reaching. I think that your site is it's closed for business. Look, so yeah, the jumps. Why? What's the main reason? Why? It comes here. So if this one, I'm going to try to ping. I don't know if this connection with terminal. I don't have no terminal here. Okay, I'll open another one. So ping zscop.eu. Oh, I've got no service. This is well, simply because I don't. Just a second. I don't have no DNS. Oh. I have no DN again. The password. Yeah. Okay. Vim at. I've got here no. Which I'll make name server. 8888. Okay, this is enough. Let's ping again. Ping zscop.eu, and it's not pinging either. Let's check here on R1 if it is possible. Ping zscop.eu. It's pinging. Wow, it's magic. What's wrong here? From this router I can ping outside. From this one I can't go outside, or even from this client I can't go outside. Why? What's the reason? Everyone knows everyone. From this client can reach this router, this one also, but they can't go out. Why? What's wrong here? What do we need here? What? So let's do here. Let's sniff some package, the interface that's directly connect to the one. So a TCP dump minus IHTO minus very verbose ICMP. You're going to check only and to catch all the package, the ICM package that will pass through HT0. So right now let's try again. So ping, and here, where is it? Quickly. No. Right now it's not pinging. What's the IP address? This is the IP address. Okay. Let me check here. Something different. Sorry. This is IP address, and enter. He has no response. Look, he doesn't say that he has network unreachable. so he's got a gateway, and here it is. He's pinging, right? He's pinging. Here it's the place where you have our site is, and he's pinging. So the package are leaving our R1. Okay? So what's happening? And why does this one, when we are on R1, you go outside? Question. Answer will give you opportunity to go to the break. If you don't know the answer, you stay here on the class. Till next week. Until we have an answer. Did you bring your brains today? Yeah? Okay. Okay. I believe you. What's the problem? What's missing here? Okay. We have here a cloud, because not today it's not cloudy, it's a very sunshine day. Sunshine. Here we have a cloud also. But before the information, the package leave our router, they'll go from this router. And this router, it's a router that's inside our installations here on CNL. So this is our router from CNL. And what's happening? He has also some network. The problem is that when he's connected directly to this router, the R1, let me check, this is R2, R1, okay. In terms of configuration, routing configuration on a VirtualBox, the router is configured, where is the, I don't have a, oops. Right now I don't have a I don't have the mouse point. What happening? Okay, the point is I don't have mouse pointing. My mouse. Let me check with another one. No. Here, Houston, we have a problem here. I can show you. But here, where is it? Perhaps here. Let me show you in this way. Settings. What's the here on settings. Oh, we've got a problem here. It's not quite good. No, this is not good. Now the system is frozen. It's still on the air. Yeah. I can't show you, but the first interface. Yeah, let me check. Oh, not possible right now. The first interface of this router is configured as NAT. And NAT, what's the use of NAT? NAT is used for what? Masquerade networks. And this router here on the CNL router knows the IP address of this one, but he doesn't know all the other networks that are behind him. So we have to configure on this router NAT network. It means that all the package will be masquerade before they leave, and then the router will give an answer back. Okay, so this is what we're going to do in the next video. We're going to make a break and see, because the system is hanging on here and we had a problem here, and so I'm going to stop the video and I'll be back. Stop. It's not stopping. It's good. It's amazing here. Okay, I'm going to stop the video by yeah. I have to go. The system is stopped. Why? Okay. I'll be back here soon.